Alright, so we're going to learn about how to add and remove from minHeap, basically a tree, right? So let's first explore the inserting any numbers in a tree. So first thing first, we're going to push it at the back right here, and then compare or happify it up with the parent, and then we're going to swap and compare again and do all over again. So it's going to look like this if we're going to push it and compare with the parent and we'll replace, and then compare with the parent and replace until we ran out of the length, which is basically index 0. So let's look at the JavaScript code here. So the performance is basically big out of n log n is the average. It's very average sorting algorithm and is worst case performance of big of n log n. So pretty good. So let's implement this with by initializing it with the heap. This dot heap. We're going to initialize with the array, and we're going to need two extra functions. This dot parent, and in this function we're going to pass index, and so we're going to turn the calculations of basically parent index. So we're going to use method of floor because it's rounding it, not rounding it up, so it's basically good for index calculations. Okay, so how are we going to calculate? Well, we're going to pass an index and minus by 1 divisible by 2 because we are going up, that means the index value is going down, so minus by 1, and divisible by 2 because we are going up by 1 2, right? 2, no, so 1, sorry, 1 2. So that's the parent index calculations. Okay, so let's go to the this dot swap. We're going to need this. We're going to pass first index and second index. Okay, and right here we're going to swap the value of the heap, not the index. Okay, so this dot heap our first index, and we're going to use that, and this will be our second index. Okay, and then copy that and something like this and like this. So this will be first index, and we're going to have to do this. All right, so this will be our swapping. Basically, this is how we're going to swap. Okay, so looks good. Control and enter and make sure that everything working correctly. And yep, no error, nothing whatsoever. All right, let's push this up. Okay, so we're going to implement this dot insert, and we're going to have a value passed here, and that value will be the one that we're going to insert. First thing first, we're going to push the value up in the tree, and that will be at the end of the tails, basically right here, right? So that will be 3. So after that we will have to heapify it up. Heapify. Okay, so for this function it will take this dot heap dot length and -1. Why is that? Because the list at the end of the list, this is like the maximum number or the end of the list, so we have to take the whole length number, the range number, minus by 1 because it's basically array linear type, right? So and that's it for the insert. So we still have to implement the heapify up. That's the function that we customized function that we have to implement. Heapify up, and in this function we're going to take index, just like parent functions, and we will have to basically heapify out. Okay, so first current index, that will be our current index, and we're going to need to calculate the parent index, which is parent index, and this dot parent. So this dot parent will take basically current. Okay, current, and let's say current index. Copy and paste that. Good. And right down here we will have a while loop, and the current index must be greater than 0, because we don't want to go over this root, right? And as long as the parent is greater than the child, we will have to swap. So this dot heap, and then right here parent index is greater than this dot heap current index. Okay, if these are true, then we have to still swap and replace. Basically, that's what we're doing. Okay, so we have to basically repeat that formula and the current index thing right down here. Okay, so this is going to be our parent index. Copy and paste that right here, and the old parent index will be the new current index, right? And then basically the parent index will be the new parent index will be the one that we calculated on top, the root, basically, in this case. All right, so this is what we are doing basically, and right here we will have to this dot swap. So after swapping it, we have to basically calculate the index. So we will have to first swap. So that will be current index, and we have to pass parent index. All right. So that's what we're doing. So that's it for our inserting in value in the tree. And yep, control and enter, make sure it's working. Yep, it is, and everything is looking good. Okay, so let's move on to our how to remove element from the tree. Okay, so how do we remove this? Well, removing is a little bit complicated. First thing first, we will have to swap the root and the rightmost, because the rightmost one is the last one, right? So swap it, and then we're going to pop the rightmost one, right? And just like queue, we just stack, sorry, just like stack, we just pop it, and then after that we will have to heapify it. I think heapify it down, yeah. So we will have to compare from left and right branch. So after comparing, much comparing, 6 is the least number one, the least value in this branch. So we swap it with the root, and it looked like this. So now 12 is the new current index and the min index. So the min index, we will calculate the new min index. In this case, 7 is this 17 is the new min index. We will make sure that with the left and right branch checking, it is not. They just basically in the right order. So in this case, we escape from the while loop, and we basically get this result, and this is what we want. Okay, let's implement that in method right here, JavaScript method. This dot remove, and a remove method will take will not take anything. So and because we're removing it from the top, which is basically index 0, right? So in this case, we will have to replace heap 0. So the challenge asks us to return the mean value, so something like that, and then we're going to return it here, min, and this dot heap will be replacing with the branch, the last rightmost branch, the rightmost node basically. So that will be this dot heap dot length and -1, and that's what we'll do, right? So if we look it up here again, so that's what we're doing, right? Okay, so now we're gonna pop the heap pop the value, the last value that we just replaced, swap, sorry, and then we're going to heapify down. In this case, we're going to send index 0. Once we pop it up down, pop it, so it's going to look like this. So I'm going to heapify it down. Okay. All right. So how are we going to heapify it down? This dot heapify down and index and like this. So in this case, we will have to calculate the left and the right branch as well. So first things first, let's calculate our current index, which is basically index, and where left index, that will be current index times 2 plus 1 where right index equal current index times 2 plus 2. Why? Well, because we're going down and the number is increasing, and from the left is +1, and to the right will be +2, because 2 node has to pass, right, from the basically from the top down approach. Okay, so that's why we're adding +1 and +2, and we're timing by 2 because this is basically is going down by 2 branch at a time. Okay, so 1 2 1 2. All right, and that's what we're doing right here, this formula. All right, and then while we will have the while loop, and just like we did for heapifying up, we will just have a similar situation right here, and this is how we're going to traverse and recalculate the left, right branch and the current index. So in this case, we're going to have min index, so min and index, and we're going to calculate that min index with this, and that will be our from our current index. Okay, so now that's what it will look like. So in this case, left index is supposed to be less than this dot heap dot length. Okay, since we are popping it, basically it needs to be within that range, and we're going down and the index value is going up, so that means we have to be within that range, and it need to be less than the maximum length. Okay, so in this case we will have to check if this dot heap and the left index value is basically if it's less than this dot heap min index value, that means we have to reset min index with the left index. Okay, and copy this and then paste it down here for the right index. we calculate the left. So right index, okay, and copy and paste it right here, and we still need to basically check for the boundary. Okay, so right index is supposed to be less than this dot heap dot. Okay, so as long as within the range, we're still good to go and calculate whatever we have to do. Okay, so and then after that we still if everything is okay and just like this, there's no new minimum index or there's no right minimum index, then we're going to break out of the loop. So if so left and right index checking is basically making sure the min index is the right minimum index. So min index is equal to current index, then we will just break out of the loop. Otherwise we will have to swap current index and min index value. So what happened the previous, basically this is between this, right? So once we swap and basically we recalculate and then move on to the next one. Okay, and if nothing's happened, break out of the loop. All right, so that's it for the removing part. Remove method, control and enter. Everything worked correctly. MinHeap should have method called sort. Okay, so we still need to implement one more function, the last function, I think. So this dot sort is the one that we going to use it for basically print out and try to get the number from the least number to the greatest number, larger number. So as we know already, the remove method will remove from the root, which is basically the least number, and then it will organize it again, do it all over again, and always going to be the least number right here. So in that case, we can use it for push it into a new array and append it that way, and it will be organize itself, right? That's how we sort it. So this dot sort, and then we're not going to take any value here. We'll just use var sorted array, and that's how we're going to do it, and return that sorted array. And right here, while if this dot heap dot length is greater than 0, then we're going to push it in the array dot push, and this dot heap dot this dot remove method will be called inside here. So now it's called, everything is good, right? And then let's press Control and Enter, and it will work perfect. So at the solutions, we got this number right here, and that's how we implement sort, add, or insert and remove in the heap minimum heap.